Okay, good morning. Now this is week 11 and the first lecture for group 2. And in this lecture, I'm going to go through the practice exam paper, part A, the multiple choices. There are 40 multiple choices questions in this part. So it's a good opportunity to give you a quick recap of all those concepts. Remember, in multiple choice, there are usually quite a different type of questions. I would say the first type of question, they are conceptual. It means it really testing your understanding of physics, the concept. The second type, we call it simple numerical. It just requires a simple formula and substitute the number and get it right. So let's look at it. Part A, the first one here. Now the part A, the first one is a classic example. It's say you have someone, a joker, is exercising a straight row. Okay, and this is north and south. Now it heads to the north, and this is your distance. So it asks you, sorry, this is your time, and this is your velocity. So you ask this question, the distance, how much the jogger cover during the first 12 minutes. Now, first of all, if you have there's three different type of graph. This is time versus displacement. The second type is time versus velocity. And the third type is time versus acceleration. So the three different plot. The first thing is you have to identify what graph you are given. And apparently you have the second type. It means the velocity versus time. But you want to get is the distance or the displacement. So you are working from here to here. Now the basic theory say if you have a graph which is velocity versus time and this shape, and if you want to know that displacement, this object is covered during a time interval, all you need is find the time interval, find this one, and find the area. This area is this time interval, how much it covers. All right. So what it means is we want to find the area under this graph. Now there's a 12 minutes, so we locate, this is 10, this is 12. So we are trying to find, you join 9 here, we join 9 here. We try to find the area bound by this graph. Okay. Now, how to do it? Now, the best way to do it, if you have a simple, say, a rectangular or a triangle, of course, it's easy. But now it's a complicated. So all you need to do is count the area. Now for the counting, I will suggest you just first focus on how many square. All right. So the way I do it, say something like this. And before I move on, I want to change the pen size, if I can. Yep. So this is 1, 2, 3, 3.5. So I can say this is 3.5. All right. Now the second row, 1, 2, 3 is 3. You add 1, 2, 2.5, 2.5, 1.5, 1. You see how I organize the counting, so I won't miss anything. And this is half. All right. So once you add, you get all this. Of course, you can use your calculator. So, or you can use your head. It doesn't matter. So you got 0.5, 1, 1.5, 2.5, 3, 3.5, and 3.5. I think is 12. You should get 12. So you got 12 square. Now the next question is, for the 12 square, what it corresponding to. Now, each square here, if you look at here, this is 1 meter per second. But here, if you look at here, this is 2, 4, 6, 8. So each here is 2 minutes. So you see here, if this is 2 minutes, this is 1 meter per second. Now, when you multiply this one, it's not right because they are not SI. So you have to convert this one, the area of each square, into meters. All you need to do is 1 meter per second multiply 2 multiply 60 seconds. So you got 102 meters. What it means, each square in this graph represents 120 meters. All right. So because you have a 12. So your total number is D. All right. So this is the way you count. Number 2. A ball is thrown into the air and follow a parabolic trajectory. Point A is the highest point, and point B is where is the ball falling back to the ground. Choose the correct relationship. So you can make a sketch as usual. So this is your initial velocity. Now remember, this initial velocity here, we solve this one is a uy and ux. So when they go to here, back to here, now the first thing here, at this point, the vertical component is 0. So it means it just as you throw a ball to the top and stay there, 0. But you still have a horizontal component, and this one is ux. Now, when you come down to here, the velocity point this direction, and what you find is the vx is the same as ux. It never changed, but here is the reverse. So if the y component, if it's say 3 meters per second, when it comes down, it's negative 3 meters per second, the y component. So, and also, if this is your theta, this also will be your theta. All right. The same, just opposite. So if you look at which is which, so first of all, acceleration. During the whole journey, the acceleration is constant. So we can show these two. Now, it means B and C is wrong. They are wrong. Look at A and D. Now, A is where? This is your VA. This is B. Okay. If you compare A and B, their velocity, apparently they same have a horizontal velocity. But B got a vertical component. So the magnitude of B will be bigger, of course, than A. So the answer is D. Number 3, a boy throw a rock with an initial velocity, which is 4 meters per second at a 30 degree above the horizontal. How long does it take for the rock to reach the maximum height? Now, again, this is 30 degree, so you have a 2 component. So this is 4 meters per second. Now this is of course a 4 meters per second cosine 30 degree. The y component is 4 sine 30 degree meter per second. All right. Now to look at the time, because how long is talking about the time is all about the vertical component. Remember, it's the vertical component control the time. It's not the horizontal. So all you need is look at here, as if this one come to here. So the time you throw the ball with this velocity to here is the same time you throw the ball with an angle with here. So we know this is your u. We know at the maximum height, the v is equal to 0. And you know during the journey, acceleration is minus 9.8 meters per second square. So you got the 1, 2, 3, the 3 important ingredient. And of course, you want to know the time. So something will come up to your mind with this equation. All right. So we solve this equation for the time. And the time v minus u over a. The v is 0 minus 4 sine 30 degree. A is negative 9.8. So everything's consistent. All the unit, the SI unit, check the unit. You can drop the unit, as I say, but check where they are all SI. Okay, all you need is 4 sine 30 degree 2 divided by 9.8. So you got 0.2. So around here, the answer is A. Number 4. Now, the figure shows velocity time graph again for a car traveling in a straight line. Which of the following statements about the car is or are correct? Correct. And now, this type of question, you have to look at each statement, 1, 2, 3, each time, and determine the true and false. So effectively, you are doing 3 true and false questions. All right. So the way usually I do it is just forget everything and look at the statement. So statement 1, the car has returned to its original position after 30 seconds. After 30 seconds. Now this is velocity versus time. It just say at 30 seconds, the velocity is 0. It means it stopped, but it doesn't say it returned to original. And if you look at what happened is, this graph probably show you like this. You have a car, t equal to 0. The velocity accelerates. So in the first 5 seconds, the velocity getting increase until 20 meters per second. And then you keep 20 meters per second until 10. And then this velocity is still positive. Remember, overall, the whole journey, the velocity is positive. So it at about 13 seconds, it stopped. So it always go to the right-hand side. So it never returned back to the original position, all right? So therefore, this is false. All right. Of course, you don't need to make a drawing during the exam, but you can do it in your head. In the interval QR, during this interval, the car moves at a constant speed. This speed is constant, yes, so this is true. The car is moving toward the starting point in RS. No, it still moves toward to the right-hand side, unless it go here. If I extend this one here, I will say between this one is negative velocity, and then during this time interval, it will go back. But now, because RS, it still the car still moves to the right-hand side, positive direction. So this is false. So the answer is B only. Now remember, I can always change the statement. So you don't just remember the answer. You have to understand and decide which statement is true and false during the exam, and then just put down correspondingly the answers. Number 5, a trolley rolls down a slope, run away from rest, and reach a smooth flat table like this. And What is the velocity versus time? Now we know during this, when you roll down, the velocity or the speed, I have to say it's really mean the speed in this case. The speed increases, and because it converts the potential energy to kinetic energy. So once you reach this one, the speed will be constant. Now, of course, this is we call the textbook problems. It means if you really think about it, it's sort of contradicting. Think about if a table really smooth, can the wheel rotate? No. The fact the wheel rotate, there must be friction. So don't worry, don't argue all these subtle things. Yeah, at this level, of course, we are dealing with an ideal. So once you reach a senior level, all the wheel, all this subtlety, you will come back into a more complicated equation. So don't worry about it. All you need to do is the velocity increases, and then we keep the same. So the answer is A. Okay, number 6. After getting on a motorway, a car accelerated from 10 to 30 meter per second. Its kinetic energy by factor. Now, again, this is a classic type of multiple choice question. You may find sometimes complicated how to deal with. Now, all you need to do is first write down the expression. It means the kinetic equation. So K, I just use K as KE as kinetic energy. So you're talking about how the kinetic energy change. So I can say this is 1, this is 2. So the kinetic energy 2, this is velocity 2, kinetic energy 1. You see, all you need to know is kinetic energy proportional to velocity square. That's it. Of course, if you really do the math, you can say you make it divide the 2, and then you have a KE2 over KE1 equal to V2 square, V1 square. And because now from 10 to 30, how many times? 3 times. So you got this one, 30 over 10 square, so it's a 9. So it means the kinetic energy increases 9 times. All right, so the answer is C. Number 7, a person with a mass of 70 kilogram is riding in an elevator which is accelerating upward. Now, there are only 4 different, well, 6 to be honest. Let's summarize, review what this type of question about. Now, if you are sitting here, if your friend is in the lift, so your friend is here. Now, first of all, if you look at the free body diagram, this is your friend. He will subject to 2 different forces, all right? The first force is mg. The second force is normal reaction, the reaction from the floor to you. Now, remember, this is the first thing you have to realize. The so-called apparent rate is your normal reaction. Just like here, you're standing on the floor, you feel you have weight. It's just because the floor is supporting you, all right? Think about when you jump from a high to the floor before you reach the ground. You don't get any support, and you feel weightless, all right? So it's the support, the end. We call the apparent weight. Got the idea first. So this is the first key physics idea. You have to turn this term into mathematics. Now, there are as I say, there's 6 different cases. All you need to do is separate which cases. Now, let's look at one by one. You can have the lift moving up with constant velocity. It means A is 0. There's no acceleration. You can have the lift moving down with a constant velocity. Agree? With A is 0. So this is the first two. You can have the lift moving up. So this is positive, moving up. But you can say, so this is positive, but you can say there's 2 different scenarios. The first scenario is accelerating. It means when you just start your lift, it just move up. So in this case, A is positive. You can, when your lift reach, say, 10th floor, it's slowing down. Agree? It's still moving up, but it's slowing down. So because this is slowing down. Now, we have to convert this idea slowing down into acceleration. Actually, this acceleration is negative. It means the acceleration vector must be point here. This is point up. All right. So if you think about it, this is if we're slowing down, reach the top floor, the acceleration actually a little bit like I always say, you throw this one up. All right. You throw this one up, it's slowing down, so the acceleration is down. So this is here. Now you have already 1, 2, 3, 3K, 4. You can moving down, so the velocity is negative. All right, so this is negative, this is positive. But when you're moving down, again, you're moving, increasing its speed downward. So you're moving, accelerating down. Faster and faster, I will say faster. The same here, actually, I will say faster. Okay, in this case, the A is negative. Because I'm moving down, you're faster. Now, you can slowing down, moving down, but slowing down. Okay, it means you're from the top floor, you reach the ground floor. In this case, A is positive. All right, can you see that all these 4, 6 different cases? Now, if you look at our question here, which case can you separate? A person is riding an elevator which is accelerating upward. So which is accelerating upward and at positive. So we have this case, positive. Accelerating upward. So we have this case. Can you see it? So once you determine this, I use the space down here. So we are in this case. Your velocity is positive. Your acceleration also positive. All right. Now, once you separate these 2 sides, this is important because now we can set up the equation here. If this is your mass, your friend, remember I say there are 2 different forces. Look at the acceleration. The acceleration positive. So what it means, remember I say you have N, you have mg. Which one should be bigger? Think about it. F equal to ma. The force must parallel to the A. So the A is up. Can you see? So the force must be up because F equal to ma. So you see, you first determine the acceleration, up. And you say, what's the force? The force also up. Now and then you ask, how many forces? 2 forces. One is N, one is mg. So in terms of magnitude, which one should be bigger? N. Got it. Now this is important. You see, all physics, they're all physics. Arguing. You keep arguing. So this is N, and this is mg. So that's why I write it this. Is it clear now? Now you have to write down this clearly on the graph paper, so you can set. Now, F equal to MA, okay? N is bigger than mg, so we say N minus mg is the difference, is the net resultant force. This is your F. This is your F, equal to MA. Can you see it? The rest is mathematics. You already done the physics here. So what you want to find? You want to find apparent weight. It means you want to find N. N is, of course, MA plus mg. So all you need to do is, I put it here, N is MA plus g. So M is 78. A is 1.7. Remember, this is what you record. Is upward, accelerating upward. That's why this is 1.7 plus 9.8. All right. So if you type this one, 1.7 plus 9.8 multiply 7. This is 897, so the answer is D. Is it clear now? And you see it's complicated. This is a classic type of question you will see in all introductory physics university course. And once you learn how to do it, you see it's not hard. It's just analyze it. And the equation, the mathematics is not hard at all. And okay, so I remove all this. Okay, we move on to number 8. Now I have to make sure I have enough time for 40 multiple choices today. Two forces which are equal in magnitude but opposite in direction acting along. Now, if, of course, you can have a two forces acting along, so they cancel out. But if you have a two forces, say for example, this is your steering wheel, you put right hand side here, you put left hand side here, so they are not acting on a straight line. They're not acting along the same line, so they're acting on a different. Okay, in this case, they can't. Yes, magnitude can be cancelled, but you produce a turning effect. Therefore, we call this one A. I beg your pardon. A is coupled. You have two forces. Number 9, a hiker descends from the summit of a mountain. So it's a hiker here from the summit. Summit is the top of the mountain, the summit. And to the sea level. During this hike, the work done by the gravity. Now, the thing about here, we all know work done is Fd, or more precisely, the dot product. So Fd cosine theta. Now, if you have an object moving to here, if you apply a force for a distance, so I say this force done a positive work because the force is to the right, displacement is also to the right. But if this time you have a friction, the friction also does work to the object. But this time the friction does negative work because the displacement to the right and the friction to the left. The same example here. If you throw the pen up, all right, so it moves up, but the gravity down. So I will say the gravity does negative work. It means it will move its kinetic energy. Negative work means get the kinetic energy out from the object. When it comes back here, the gravity does positive work because the force and the movement are the same. So it's all about whether they are the same direction or opposite direction. Here, it moves down here. So the force is here, mg, the W, the gravity. The displacement is also down, so they are same direction. So I will say positive. But it won't depend, it doesn't depend or independent of the path diff. So it's C. This is a special properties of gravity. We call this property if the force, the work done by force, doesn't depend on the path. We call this one conservative. If it is this property allow you to define potential energy. If the force is not conservative, there's no potential energy allowed. All right, number 10, a string is tied with two spring balances. So if you record this 120, of course you will get the same 20 newtons. So this is C. Number 11, after getting on a motorway, a car, this is the same question, don't worry about it. Yeah, it's C. What's the power developed by the engine? Now, a power by the engine. So you got, this is your velocity. You got the velocity. You got the force. Because assume this is constant. But one is your power, the force from your engine. One is the frictional force, the friction. They must equal. Otherwise, you won't get a constant velocity. Now, if you have a force, move an object from here to here with a D or X, at this time I use X. Remember the work done is Fx if they're parallel. But what's the power? The power is work done per time. So it means Fx over t. If you collect these two, this is F velocity. Can you see it? So all you need is the F 100 Newton, multiply this one. This is your power. So that's why the answer is A. Number 13, a roller coaster car moves on a track with one section. That is a vertical, so this is a vertical. When the car is at the top of the loop, it just maintains contact. Now, same again here. When the car here, there's a two forces. One is mg. The other is normal reaction. Now, this time is from the track to the car. So even this is upside down, the track will give the normal reaction to here. So it means there are two here. So you will say the total force equal to ma. The total force is mg plus the normal reaction. They are the same direction this time. Of course, when you under here, this is your mg, this is your normal reaction. So it's a different when the car is on the top or at the bottom of the track. We are at the top, so they're the same direction. Now A, what's the A here? The A, of course, is centripetal force, V squared over R. What's the car's acceleration? So it means this is your acceleration. It means we don't need to write down explicitly V squared over R. All we did is mg plus n equal to ma. Now, it say, this is important, it say it just maintain contact. It means this statement means n equal to 0. Now this is the hard bit about engineering and physics. You have to know how to convert the idea, the statement, the observation into mathematics. All right. So you have to know when it just maintain the contact, it means there's no normal reaction, and it means n equal to 0. So n equal to 0. So you cancel. So A is equal to G. All right. The G, of course, is downward. So G downward is D. Number 14. What does the moment of inertia? Moment of inertia. Remember, we will be given the whole table if you need in the exam. It's defined as if there's a rotational axis, if the object is rotating here, and this is your mass. The moment of inertia of this mass, point mass, is equal to mr squared. All right. So this is your moment of inertia. Now this is so what does the moment of inertia describe? It describes the mass of an object is distributed about a rotational axis. So the answer is B. Because when you have point, if you have a disk instead of a point, your disk is just have a many different points. Can you see it? So it's just how those masses distribute. Number 15. Two uniform disks have the same mass, and now you may need to recall how the disk, the inertia is half mr squared. So this one is 1/2 mr squared. This is 2/2 mr squared. They have the same mass, but you see the r is 2r because r squared. So I2 is 4 times of I1. So the answer is D. The angular momentum. Now, linear momentum. Remember, F equal to ma is all our starting point. And F is m delta v delta t. So delta mv delta t, we will define this one as momentum. So for the linear case, momentum P is defined as mv. Now we have the same analogy here. Remember, when you do from the linear to angular, this is how we make analogy. Angular momentum is equal to mass become I, v become angular velocity. So it's the product of moment of inertia and angular velocity. The answer is C. Number 17. A simple pendulum has a period t on Earth. If it were used on planet Earth, the acceleration, again, you see this is, as I said, that's a classic example, because all you need to know is write down the expression, which is the period is equal to 2 pi square root L over G. All right? So once you get this one written down in front of you, you will say, now this, what it means is, you see that the period is proportional to 1 over G. All right. Now, alternative, you can say the period multiplied square root G is a constant. It doesn't matter what you say here. Now, if you see, if the gravity is 3 times, so the nu is 3G, okay, and of course this is you don't need this one. So the nu is 1 over square root 3, so this C. Number 18. An object undergoing simple harmonic motion, which is the maximum. So, yep, whenever what is the object's displacement? So, first of all, you have to write down an equation. For the simple harmonic motion, this is your equation. Now, there are two ways to write it. You can write sine omega t, or you can write a cosine omega t plus phi. This is the phase angle we call. Now, therefore, it is important to know what equation you use, sine, cosine, or a general equation. The hint is here. It has a maximum displacement at t equal to 0. So, sine or cosine? Which function have maximum at t equal to 0? Cos. So, you know that's why you have to be careful. And you are talking about cosine. So, we'll use this one here. A is 6.2 meter cosine. You know the angular velocity 1.6, so you want to know 3.5. So you may find, okay, this is easy. This is 1.6 multiply 3.5, so you got 5.1. Now be careful what the 5.1 here is. Radians. So you, as I always say, make sure you convert this one into degree. If you leave your calculator in degree mode. So 5.1 multiply 180 divided by pi, and then this is cos 292.2. So this is cos multiply 6.2. So it's a 2.3. Something wrong. It's 5.6. Yeah, it should be. I try again. What's wrong? 1.6, 3.5, 1.6 times 3.5, 5.6 exactly. This is 5.6. Yep. So this one is times 180 divided by. So it's it makes sense now. 320. So cosine multiply 4.2 is 4.8. All right. Number 19. Well, quite have to be. The graphs show the velocity against time for an object in simple harmonic motion. When is the potential energy maximum? Now you got the velocity and t. So just recall what happened. Okay, this is oscillating here. All right. So this is moving like here. Now when at the equilibrium position, the velocity is maximum. It's either this way or this way. When it reaches the two ends, the velocity is 0. The velocity is 0. Got it? It asks you potential energy. Potential energy is you either stretch the spring in the maximum or compress it. So it means at this two, the potential is maximum. The potential energy is maximum. At this point, the potential energy is minimum. So you are looking at the point where velocity is 0. Got it? So this, and this. So it's a 0, 4, 8. The answer is A. You see, it's all about your concept. It's all about your concept. Now, number 20, I beg your pardon. I gave you the wrong answer in the answer sheet. So let's look at it. the intensity of an isotropic sound wave. Now, you imagine this is a power point source, and it spread its intensity to the sphere. So you want to know each unit area here, how much energy per second. This is the definition of intensity. So intensity is power per area. And because you're at a point source, you spread like a surface. So the first surface is 4 pi r squared. So it means I is proportional to 1 over r squared. So therefore, it's inversely proportional to the square of the distance from the source. The answer is D. All right. Number 21, a string. Now, if you just let you play a guitar, the string oscillating, and the wave speed is 150. Now, look at the speed. The speed is V is here. And you want to know, so you know the velocity is 156 meter per second. You want to find frequency. Do you want the wavelength? Yes, you can find out from here. So this is your 2 meters. All right. So the wavelength from here to here, there's 1 wavelength. How many wavelengths? 2. How many? 3. So 3 wavelengths is equal to 2 meters. So your wavelength is 2 over 3 meters. All right. So frequency is V over wavelength. The V is 156. This is 2 over 3. So it's 156 multiplied 3 divided by 2. So it's a 234 hertz. So the answer is B. Now number 22. Number 22, you have a 2 wave sources. They're both coming from S1 and S2. And the 2 wave sources, they are at a point P. And now it really depends. It really depends. I mean, you can be any, but when you add at here, you can have trough to trough, and then you have a constructive. You can have trough to, crest to crest, and trough to trough. You have a crest to trough. You have a destructive. So this one you enhance. Now, how to do it? First, you have to look at is the distance. From here to here is 1 meter. From here to here is 3 meters. So the difference, the delta D is 3 meters minus 1 meter. So it's 2 meters. But at the same time, the lambda is 4 meters. So if you over this one, can you see this is 2 over 4 lambda? So it means half lambda. When you have half lambda difference, it means this is the first one. The second one is half, you shift half lambda. So when you add this one, it's 0. Therefore, you got a destructive interference. All right. Follow? Number 23. Number 23, if you have the same materials here, they must equal. This also equal. So the answer is D. Number 24. A circuit contains 2 unequal resistance in parallel. Now, look at here. If this is 1 ohm, if this is 2 ohm, they are unequal. Now, if they have 1 volt as a potential difference, so what's the current? Of course, the current here is 1 amp. The current here is 0.5 amp because Ohm's law. So you can see if the two resistors, if they are connected in parallel, the higher the value, the lower the current. So the current is the same, is force. Large current flow in the, this is force. This is the same. Actually, this is true. Force, the answer is C. Beg your pardon, this is also centimeter, 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 centimeter. At this point, this pressure here, P, is equal to 20 centimeter height of mercury plus 1 atmospheric pressure. All right. However, you're asking the gauge pressure. It means you ignore, you just subtract the atmospheric. So this is your answer. So this is A. You are above. A hydraulic lift. So remember, the pressure at this point is equal to the pressure at this point. So the pressure at this point, P, is F in pi r square. At this point, I use a smaller. F in pi r square. At this point is F out pi big R square. They must equal. These two must equal the same pressure. So the out over the in is equal to R square over R. Yep. So square. Now, of course, 550, so it's a 10 times square, so it's a 100 times. And you're putting 88, so you will get a force is 88 multiplied 20, so it's a B. All right, number 27. Two resistors, R1 and R2. One is 6, one is 12, and this is 2 ohm. You got 3 amp here. What is the net potential? What is the potential across? So what you can do is you can, okay, this is 3 amp is your total current because you're measuring at this loop. It means it's the same as this one. So this is your total current. So you first will find the equivalent resistance. So you got 6 and 12 here. So if we write this one is here. This is 2 ohm. What is this one? This is easy. 1 over R, 1 over 6 plus 1 over 12. So 6 plus inverse 12 and then inverse 4. So this is your 4 ohm. So your total equivalent is 6 ohm. And you know the current here is 3 amp. All right? So therefore the voltage is IR 3 over 6 is 18 volts. So the answer is C. Number 28. Suppose you have a parallel plate capacitor to a battery fixed potential difference. If you increase the plate distance, so remember this is D, and you got the A here. So the C is epsilon D A over D. This is how you made a capacitor. It's not the definition. Definition of capacitance is charge per unit voltage. You should want to store charge. How much charge if you apply a certain voltage across the two plates. This is how you made it, how you measured it. So it's a two different definition. If you increase, so if this one increase, of course C decrease. So it means the capacitance decreases. Answer is B. Number 29. The electric current as a function of wire is plot. Okay, what is the resistance? Now be careful. V equal to IR. Usually, if you plot V versus R, if you plot V versus I, the slope is your R. But this time you plot inverse. So be careful. It means now I is plot 1 over RV. So this is your Y, this is your X, and this is your M. All right. So your slope is reverse. Now all you need to do is find this point. This point is 10 volt and 6 amp. So your slope is 6 over 10, but your resistance is inverse. So your resistance R is 10 over 6. 1.7 and 1.6. Now this is a network, a sort of complicated resistance. Now the network is easy. You got this one here. The best way is withdraw. If I withdraw the circuit, do you think it looks better now? Now this circuit is equivalent to this circuit. Now once we can withdraw the circuit this way, it's easier. Now how about we just put R and R? We make it more generic. So there are two parallel. So half. So this is R. This is the equivalent is half R. You still have another R. So you just add. So you got 2.5 R. Okay, 2.5 R. It means 2.5 times 160 ohm. 400. All right. Number 31. Now, when you have a positive here, what you get here? Negative. So you got positive this side. Now you separate. So your negative still here, your positive still here. So this is negative and positive, C. Number 32. Which statement below regarding now is all about whether you can recognize an equation. The P is what? Pressure. So pressure is measured in Pascal. V is volume. So it's meter cube. And is number of mole. All right. So it's just a number. R is a gas constant. It's 8.135. T is, of course, is temperature. This has to be in Kelvin. So this is A is force. R is a constant. So it's not different. It's not velocity. So this is true. D. Number 33, again, now the most important part is redraw your diagram. Now, if I redraw this diagram right here, you have a two path, and then this go to, so you can say this is this one, C, This is junction here. This is A. This is B. Can you see how I write it? This is this one and this one. Now, once you split in the top one, you pass through the C. Pass through the C, you split into two. Can you see it? Rejoin. Exactly. So once you withdraw this diagram, it's a lot easier. Can you see it? Now, the next stage, of course, find the equivalent capacitance one by one. Usually, the way we do it is like this. We first find these two, all right? And these two, we just assume this is C. Remember, in a capacitance, if you have a parallel, you add, all right? So it means this circuit now, it becomes a, this become a, here. And this is C, this is 2C, this is C. Now, the upper branch here, the upper branch here is series. So remember, this time is different. It's different. You add it reciprocally. The new, I use a pi here, is equal to 1 over C plus 1 over 2C. All right. So the 1 over C pi is 2C, 3C, 3, I beg your pardon. All right. So the C pi is 2 over 3C. What I mean is here, this is 2 over 3, this is C. All right? Now, you have to add this time. So you have to do it one by one. Yes, it's complicated, but it can be done. You turn this one into one simple. So this is add. So it means 5 over 3C. Now remember, what's a C? C is 10 mil. So you got 5 over C. So it's 50 over 3. You got 16.7, 16.7, A, the answer. All right? Hope you follow. Number 34. A laboratory experiment is run at what is the expression? So 273 plus 42. This is all you need. It's minus. Now, this is just telling you that coefficient of expansion of the linear is 3 times of the volume, or the volume is 3 times of the linear. If this is 0.1% expand, the overall expand is 0.3% positive. Number 36, the heat required to change a substance from the solid to the liquid is referred to, remember that the graph we're looking at, this is the time. We boil, we put the ice, so this is the temperature. So here, 1, 2, 3, this is 0 degree, this is 100 degree. So there's a certain times the temperature doesn't change, but you're still putting heat, thermal energy into it. And in this case, this is we call the heat of fusion. It is well known that now let's look at specific heat. This is mc delta T. Can you see it? Now you have water and iron. they're thermally, so it's so you have the same Q, you put the same Q, but because the same mass, now consider equal mass, so the mass the same, so this is a constant. You see, the higher the specific heat, the lower the change of temperature. So they will have a different temperature. So water will have a lower temperature. So they no longer in thermal, so this is wrong. Water is less change. It means the iron is higher temperature. So therefore it's B. Number 38. What's the phase change here and here? So it's a B, C, and D. 39. The internal energy of an ideal gas is depends only on temperature. And actually it is a U, is a factor, numerical factor, is N number of, and K, and this is delta T. All right, the change of temperature. A heat engine does, now if there's a high temperature, there's a low temperature, there's a two, there's a cool or hot and cool side. You draw some energy from the high temperature, it explodes in the cylinder. You convert some of the energy into work done, and some of the energy you put it into the cold side. So this is QC, QH, this is work done. So the conservation of energy, say QH is equal to work done plus QC. All right. Now the engine does 800 work, so this is 800. Dumb, so this is 2836. So what is the total initial joule? Initially you got 3636. Now what is the efficiency? Efficiency is how much work done. This is input. Ideally, you want to convert all 3,636 joule into work. This is ideal. But it means this is what you really want. You put all the energy to work. But it won't work because this is nature. There's a second law of thermodynamics. It say it just won't work. So you got a efficiency. The efficiency is how much work done you get, which is 800 joule over how much you initial input. So this is 0.22. So the answer is A.